We're discussing probability calculations at grade 12 level. Two events, A and B, are independent. We've been told these two events are independent, and this is extremely important. Now, the probability of A is actually 0.4, and the probability of B is 0.5. Then we need to find the probability of the intersection of the two events. What is the probability that the A happens and B happens? But because these are independent, we need to remember something, that this is the same as actually the probability of A multiplied by the probability of B, like that. What is the probability of A? We agree that the probability of A is actually 0.4 multiplied by the probability of B, which is 0.5. And we have the answer to this. And if you multiply the two, you get 0.2. You get 0.2. Right, so we continue. Next, I want to reduce the size of these. Just 1 minute. Okay or not? I feel okay. Let's me see. All right, let's just continue. Right. If you look at the next one, the probability of A or B is that one. So, what is the probability of A or B? So, the probability of A or B can be seen as follows in 1.2. So, we have the probability of A or B. What is this? So, this is actually the probability of A plus the probability of B minus the probability of A and B. Right, what is the probability of A? Okay, probability of A is actually 0.4 plus that of B, which is 0.5. These events are independent, and therefore the probability of A and B is the product of the two probabilities, and therefore we have got that as 0.2. Using a calculator to compute the result, we have 0.7, and that is the answer. We are doing next 1.3. Right, the probability of A primed and B primed. So the probability of A primed and the probability of B primed. And then this actually becomes what? If you have the probability of A primed and the probability of B primed, what is this the same as? Right, it is the same as the probability of A, because we need to look at the fact that we have A and B there. So it is the same as probability of A or B, all primed. And if you have the probability of the complement, it is actually the negative of that. So it is 1 minus the probability of A or B, which is 1 minus. What is the probability of A? Right, the probability of A is actually of A or B. We have already got it here. It is 0.7. So we put 0.7 here. And therefore, what is the result here? Which is 0.3. So that's what we get. We continue and we look at the survey. There's a survey that was conducted. Right, so if the survey was conducted, I want to reduce this one size down. The thickness of my writing. Let's just see how that is going to do. Right, so let's continue. Okay, if you look at the next question, it's about a survey. So a survey done in a certain country showed that most people are carriers of a deadly disease. Out of the 1,200 people tested, findings were that 270 out of 480 adults tested positive, and 480 out of 720 children tested negative. Okay, so you have the 720 children tested negative, or 480 adults tested positive, and 480 out of 720 children tested positive. Okay, right. Determine the values of, so we need to learn these two-way tables. Right, so these two-way tables, we have adults and children, positive and negative. And obviously we have the values of A, B, C, and D, and hence copy and complete the table below. It's what is the matric syllabus. So I wanted to have a repeated coverage of these just to make sure that we prepare for the session that is coming on later. The probability that an adult tested positive, what is that probability here? Okay, right. So first, determine the values of A, B, C, and D, and hence copy that and complete the table below. Let's find the value of A. What would the value of A be, for example? Okay, obviously we agree that the value of A would be what the total is going to become 480, and therefore what do we add to 270 to get 480? Right, we can say 480 minus 270, and it is nothing other than 210. So we shall have exactly 210 there. Right, and then the next thing is, if you look at B, option B, same thing, it's 480 and then it's 720. What do you add to 480 to get 720, the total in that row? But also you can say 720 minus 480. And if you do that, you get the value of B. And your class activity is following next, meaning B is actually 240. Now your homework is the next one. What do you think is the size of, what do you think D equals? Can you try that one, please, in just a split second? I know it's easy.
So D is 690.
Well done, 690. Thank you. Right, so the probability that an adult tested positive, right, we have just some basic probability calculations here. So what would the probability that an adult tested positive? Right, I'm going to do one example and then the next one is yours, and we shall alternate in an attempt to make sure you practice alongside. So the probability that an adult tested positive would be, now let's look at the adults. The adults themselves are here, and you can see that you have a total of 270 adults that are positive, and now the total is 1,200. So you'd have a total of 270 divided by 1,200. So this is going to be the probability that an adult tested positive. Right, the probability that a person randomly selected tested positive.
Sir?
Yes, please.
So why are we not saying 270 over 480?
Okay, that's a good question. Why are we not saying 270 over 480? Right. Right. Obviously, that's a good question there that you're raising, to say why are we not saying that? But the point is, when we do the probability calculations, we always focus on the actual total number of the people altogether in the group than just a specific sample. So obviously it is standard practice, I hear you. So I will accept that in this discussion, we shall consider the fact that the adults that tested positive are these, and over the probability of everything in the sample space, and therefore everything in the sample space will be the total number, which is 1,200 in the overall investigation. I hear you, but obviously that the adults themselves are 480. Right. I'm going to look at other instances where it is appropriate to consider a subtotal like 480. Right. So, but at this point, I will actually insist on the total number of subjects that are being investigated or that are being tested. And out of 1,200 people tested. So in essence, because one, the probability that an adult tested positive, right? So obviously the adults themselves are 107 that are positive over the total number of everybody. Okay, I'm gonna do examples on this. Okay, there are a couple of examples I'm gonna do. You're gonna see, okay, what you're talking about. Okay, let's proceed. 2.1.3, the probability that the person randomly selected tested positive. A person randomly selected, what would the answer be? Let's look at that one. Right, a person randomly selected would become what? So in other words, we're looking at just people in general. Right, so people in general, how many are the people in general here? Obviously, you need to look at that very carefully. So you need to determine what is the value of C, for instance. Okay, we had not determined that one. Right, so C will be the sum of this. Then C will be exactly 510 if you add everything. So the probability the person randomly selected tested positive would be the total number of the people, because we're looking at people, like a person, anyway. Right, so which means that now how many people are there? Quite, that tested positive. There are 510 over the total number of all subjects, 1,200. Okay, next. The total number of children who are positive, if the estimated population of the country is 40 million, right? We're looking at the number of children who are positive. Let's look at the children who are positive. We have 240 children who are positive. But now, if we have the number of children who are positive and the children who are positive are 240, so we'll agree that the probability of children positive, right, the probability of children positive is equal to what? How many children that are positive are there? Okay, we look at children positive, only 240. Over what total? Over the total number of all actually subjects here that are being investigated. Right, and we have 1,200. And therefore, you can simplify this one to 1/5. Right, so are the events of testing positive and being an adult? Yes, okay. Testing positive and being an adult independent. Let's check. Right, so we're looking at 2.2. So if we let here the you let A be the testing positive, and B being B being what? Being an adult. Right. Let's look at this now. Then the probability of what they want, right? Being an adult, and so we looking at testing positive A, and then now the probability of testing positive is going to become what? Right. You have something to remember, obviously, in this particular question. Right. The probability of testing positive, we have found that already, and we need to compute that. But you know that the total number of children who are positive, if the estimated population of the country is 40 million. Right, so what is then the probability of testing positive? If the probability of B, for example, I'm going to write here, of being an adult, All right. We continue. Right. So now let's look at the probability of being an adult. What is the probability of being an adult? Okay, so it's 480 over 1,200. When we calculate these probabilities, mostly we consider the main total for the probability as the total number of subjects being investigated. Right. So let's continue now and look at the probability of testing positive. Right, the probability of testing positive. Right, so obviously a couple of things you need to consider. The probability of testing positive is A, and we remember we did that one in 2.1.3. The probability that a person randomly selected tests positive. So we found that one to be 510 because positive, either adults or children, 510 over 1,200. And then we simplify this one to the number. We simplify both of this. Okay, this one simplifies to 17 out of 40. This one simplifies to the 480 out of that simplifies to 2 out of 5. What would the probability of the intersection therefore be? So in other words, the probability, the events are they independent? So we're going to look at multiply them. Right, so we look carefully here. Get the probability. The probability of testing positive times the probability of being an adult so you have 17 out of 40 of the A part. The B part is 2 out of 5. The probability of being an adult is 2 out of 5. And then if you multiply these, this is 17. If you multiply these, what we're getting is 17 out of 100. And then now, what is the probability of A and B? The probability of testing positive and being in adults. Okay, so we need to look at that one. So we can easily do that part. The probability of A and B. Okay, the probability of A and B, in other words, we're looking at the probability of testing positive and being an adult. Okay, let's look at adults testing positive, and we're finding a total of 270 of those. Yes. Okay, being an adult testing positive, we have 270. Yeah, but divided by what? To find the probability, we must divide by 1,200. And then now this simplifies to 9 out of 40. Okay, what is then the probability that here? Okay. Now, let's look at the probability that so we multiply them. So we need to check the probability of A times the probability of B. We are comparing it with the probability of A and B. Okay, we use the intersection notation. Okay, but you can see that 40 out of 10 is not equal to 17 out of 100. So which means that the events are not independent. Not independent. Okay, let's look at more questions on the probabilities. Okay, we're gonna do a lot of questions on probabilities. So yeah, just get ready. We're gonna do lots, but this is one of the metric type of question. So you'll see a question like this that is about a two-way table. Then we're gonna look at questions that are about vans, Venn diagrams. Let's look at the next one. Okay, sometimes you might be able to count like this one. Now we're looking at the number plates, and now I said we have one this session, another session later on. We shall discuss the time. Okay, the Gauteng province. This is a question about Gauteng. The Gauteng province uses a coding system of number plates with 2 letters followed by 2 digits. So you have 2 letters followed by 2 digits. Okay, if they say this in the matric exam, how many letters are there altogether in English? There are 26 letters. How many digits are there in mathematics altogether? Anyone?
Infinity.
I'm just teasing you because I just want to test your ability to, because this is like basic. We've not like done the question, but you must like know how many digits are there in mathematics altogether. How many? What do you think, Tanula, again, please? Okay, let me see. All right, I can see Tanula thinks they are infinite. Marang, your thoughts?
So I can't hear.
Please come again.
So I can't hear properly. There's a lot of noise in the background.
All right. I'm wondering why the noise. Sorry. Okay, just a minute. All right, I'm sorry that you cannot hear me very well. I'm asking the question to say how many digits? How many digits are in math? That's my question. How many digits are in math? Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the digits we use in mathematics. No other. And these are 10 digits. Okay, there are 26 letters altogether, counting A, B, C, D up to something else. Z, the 26 of them. So we're saying the Gauteng province uses a coding system of number plates with 2 letters followed by 2 digits, then 2 letters. Okay. 2 letters followed by 2 digits, then 2 letters. 2 letters followed by 2 digits, then 2 letters. All codes end with GP, as shown. All of them end with GP. The vowels R, A, E, O, U, and Q may not be used. Okay. And digits 1 to 9 are used. Okay, that's interesting. So they're deciding that they're using digits 1 to 9. So if they're using 1 to 9, how many digits are those? There are only 9 digits. 1 to 9. Okay, the letters and digits may be repeated. Right, determine how many number plates with different codes can be made. 3.1. How many number plates with different codes can be made? Let's do 3.1. So to do 3.1, you need to draw a table like this. You need to draw a table. And then partition this here. Partition it like this. Okay, then you have 20, then 20. 20, 20, then 9, 9. Then 20, and then 9. Okay, now we have 1, 2, 3, 4, 5, 6. Okay, so obviously you're looking at the fact that you have 2, like DW. Then we have 6, 8, like in this number plate. And then you have then RH. And then the GP is the same. All the cars have GP in Gauteng, so it makes no difference. The vowels R, A, E, O, U, and Q may not be used, and digits 1 to 9 are used. The letters and digits may be repeated. Okay, let's look at that. So, if the vowels, this one may not be used, how many are we cutting out? 1, 2, 3, 4, 5, 6. So out of 26, so we are effectively therefore saying 26 minus 6, which is 20. So in other words, here we shall have 20 choices. Right, we shall choose from 20 letters to put here. Because we are cutting out all the vowels R, A, E, O, U, but we are also cutting out Q. Okay, right. So here we come. The letters may be repeated, repeated. So in other words, here if you chose D, we could put a D there. So in other words, if we choose 20, we can repeat. So we have a choice of like 20 letters to choose from. Now we come to the digits. So we have these digits here. Right. The digits 1 to 9 are used. How many digits are we going to have a choice from? So we can choose from a total of, right, 9. Right. So you have also, this one is 9 digits. And then now you have R and H. Right. Okay. Now if you have R and H, how many letters are here? So you have now the letters you can choose again from the 20 that they are there. So you have 20 choices. For the first letter, you can choose and you can repeat again and choose 20 and choose from 20 letters. So now if they ask how many, so what is the answer? Okay, so now you have 20 times 20 times 9 times 9 times 20 times 20. So what is the answer to this? So this is 20, 20, 20. How many of them? There are 4 of them. So you have 20 to the 4th power multiplied by 9 squared. And then what is the answer? It's 12 million. 12,960,000. Okay, please try number 3.2 for me. And then I'm gonna do the corrections now. Penulo and Marang.
Yes, sir.
Please try 3.2. Then I'm gonna do the corrections. Okay. Please try 3.2. Then I'm gonna do the corrections now. I'm gonna with you. Right. So you have that. Okay, anyone, you let me know when you're done. You let me know when you're done. Right. Let me know quickly when you're done. When I do the corrections, we're practicing. 3.2 is where we're at and is what we're on. Right, so you have this here. Right, so if anyone is done, please let me know. Please let me know. Right, you let me know if anyone is done. Right. Right. Anyone finished?
I'm done, sir.
Okay, excellent. Tsenulo, before we do the corrections. So Tsenulo is gonna tell us if,
It's fine. You can go on, sir.
okay, that's
You can
okay,
do the
never
correct.
mind. Yeah, we shall just proceed. I'm just testing you, obviously, so that I can be sure that, you know, you are following and whatnot, whatnot. All right, never mind. If one person is done, then we move on. Okay, 3.2. Okay, let's do the corrections. Determine the probability that a code randomly selected will consist of even digits which are not the same. Right, so let's look at the even digits. Okay, you shall mark. I'm going to ask you if you got it right or wrong, because now I can't ask because we've not done anything. Right, so in other words, we're looking at the even digits. What are the even digits? Okay, so these are the even digits because we could have put a 0, but yeah, 1 to 9. So we have that. Then let's find let's count here. If you count, then we shall look at this entry table like this. And then you have 20. Okay, because we look at the letters here. There are 2 of them. Then another 2 digits. Then another 2 letters. So which means now we have the even digits. First we do the letters, they are 20, 20. Then how many even digits are there? Okay, they're not the same digits. So how many digits? There are 2, 4. So now you deal with first the 2 letters, 20, 20, and then the digits come here after the first 2 places. Because in the case of the letters, you'll have a choice from 20 letters. After you've chosen the first letter to put there, maybe a D, then the second one you will have to choose from 20 letters. So you have 20 choices. Right, now when you come to the middle here, you have the digits to choose from. There are 2, 4 even. So you have 4 choices of digits to choose from. So you have four choices to make. And then after that, maybe you choose a 4, then the digits, the even digits which are not the same. So it means that if you choose 8, you'll cross it out and then you'll have the 3. Then you can choose from only 3 to avoid a situation where the digits are the same on the number plate. Right, and then now the letters are the same, so we still have 20, 20. Right, we still have 20, 20. This one you can remove. Right, so now, what is then the probability that they want? Okay, to do the probability, first we have to counter the number of number plates. So here it's going to be 20, 20, 20, 20, 20, which means it's 20 to the 4th power times 4 times 3. Which is equal to 1,920,000. Okay, right. What is the probability here? So the probability here is going to become, okay, now we come to this. What is the probability? The probability is going to become the restricted case over the total of everything. So the probability is going to be 1.9,920,000 divided by 12,960,000. And then you simplify this, which is 4 divided by 27. You can write it as a decimal fraction. Right, so you can check yourselves. What do you think, Marang, of this answer? Any
But I
idea?
got it right.
You got it right, eh?
Yes, sir.
Thank you so much. Okay, right, we're continuing with more questions. Okay, take a look at this one carefully because I'm moving on to the next one. Right, so the next one is going to become, let's check. Okay, we're going to spend some time on finance because I need to test your finance skills, please. Your timeline skills, just to make sure that you're good when it comes to those. And then now, let me see. I want us to dwell on what you call exemplar assessments. Exemplar assessments. Right, I have tons of questions here. So okay, yeah, I'm gonna do this one. Very, very nice question. Okay, this is really exam type, so I just need to make sure that you are very aware of this. So let's look at question 3. We're looking at question 3 because this one is scatter plots are paper 2 normally, unless otherwise. Okay, let's look at 1.3.1. How many different letter arrangements are there, for example? If you have the following, right? So you have let's look at consider the word letter. The word is letter. So if the word is letter, then how many different letter arrangements can be made out of this word? Okay, I'm giving you 2 minutes. Please try it, then I'm going to do the corrections. You let me know when you're done. You let me know when you're done. So you let me know when you're done. Okay, we are practicing, folks. We are practicing.
Answer.
Okay, done. Okay, gonna just be checking now. Right, okay. She is done. Marang is done. Okay, we are just moving forward and obviously we're practicing. We're trying now to see how well we can do that one. Right. Okay, we can just do it just now. Shall do it just now. Okay, there are lots of probability questions we shall do. So yeah, stay tuned. Stay tuned. Right. Stay tuned. Or stay put. Right, we're looking at question 3. And we're looking at question 3.1. Right, we're looking at question 3.1. Okay. Right, we're looking at the word letter, and now looking at the word letter, there are a couple of things you need to consider. Right, so the word letter has how many letters? There are 2, 4, 6 letters. So in other words, to determine how many different letter arrangements can be made out of this word, you need to look at the fact that there are 6 factorial, the letters you can choose the letters in 6 factorial ways. After that one, you divide by the popular ones, by the common ones. Like how many E's are there? There are 2 of them, so you have 2 factorial. How many T's are there? There are also 2 T's, and then you have times 2 factorial. If you use a calculator to simplify this, it becomes 180, and that is the answer. I believe Marang was able to get that one right. What is the probability that such a word will start with the letter E? What is the probability that such a word will start with the letter E? Right, let's look at these. In 3.2, if it starts with the letter E, what is the probability here? Now, if it starts with the letter E, in how many ways would we deal with this? Okay, this is how we think about this one, 3.2. Okay, because sometimes these questions can be a little bit tricky. So what you do is we have a word that starts with the letter E. So you put the letter E, and then you can organize the other letters like L, T, T, E, R. Okay, so this letter is out, and then you have this. Now, you then say, to do this 3.2, you need to look at the total number of arrangements in the whole sample space, because we do probability with like that. We look at everything total. So that's going to be 6 factorial divided by 2 factorial times 2 factorial. And then this one is 180. Okay, we've already done these. But we must do it even when we want to find the probability of a specific arrangement. So the probability, the event of the number of elements in the event of actually starting with the letter E. Start with the letter E. How many? So we start with letter E, we fix this. We fix the E, then we can arrange the letters, other letters. So we have 2, 4, 5 letters to arrange. Right. So in other words, we have a total of 5 letters to arrange. So they can be arranged in 5 factorial ways, divided by the others that are the same. So we have 2 T's that are the same, 2 factorial ways. And then the others are all different, LER. And then now you divide this, and it gives you 60. It's like 5 factorial is 120. It's 5 factorial is 5 times 4 times 3 times 2 times 1. Now, what is the answer to this question?
Sir,
So the probability that they want here, so the probability of selecting an E, the probability that a word will start with the letter E is going to become the 60 divided by 180. Okay, it's the probability of actually the number of elements in the event divided by this overall sample space. So it's 60 over 180, and you can divide that, you can simplify that one to 1 out of 3. Okay, we'll look at more things, probabilities. Okay, we'll look at more things, probabilities. So what do we say here? What do we say here? Next one. What is the probability that such a word will start and end with the letter E? Okay, I'm giving you like 2 minutes, and then please let me know when you're done, then do corrections.
What must we do, sir? What must we do?
3.2.
No, okay.
Yes, 3.2. Then we're going to do corrections. Because I'm trying to make you think a little bit. Otherwise, everything is obvious in the exam. But we can't just say, you can't just say in the exam, okay, the exam is obvious, then you don't write anything. Because you must write something. Right. Okay. I know it's tricky, but you are learning. You are learning. Okay, anyone done? You are learning.
I'm done, sir.
Okay, thank you so much. We're gonna do the corrections now. Remember that I'm not fault hunting. I'm not trying to cause you pain. I'm trying to get you to learn. Um, so yeah, stay tuned. So we have that. So right, let's do the corrections and then we shall see what we can do. Right. So here in 3.3, what is the probability that such a word will start and end with the letter E? So in 3.3, we do the same. We're going to discuss the corrections to this and then we'll decide. Like I said, so if a word starts with the letter E and ends with E, right, in 3.3, so it means, therefore, you shall look at the fact that the N in the total sample space would be the same as a total of 6 letters divided by the two popular ones, which is 2 factorial, and therefore this is 180. And then now n of these, which is, it starts with the letter E and it ends with the letter E. So if it starts with the letter E, it ends with the letter E, we're dealing with letters in the word letter. So we start with E and we end with E. So it means that we have 1, 2, 3, 4 letters to organize because we do these sometimes. 1, 2, 3, 4. Okay, suppose we start with E. Then we have, start with E, then we have 1, 2, 3, 4. 1, 2, 3, 4. We start with E and we end with E, then we have L, T, T, R. So which means therefore we start with E and end with E, then we have 4 letters to arrange, to organize. Okay, so we have 4 factorial ways to organize the letters that are remaining, divided by those that are the same. Only 2 T's are the same, and therefore the answer is 12. Now, if you then continue, okay, what is the probability that such a word will start and end with E? I said that so we can do the probability. So the probability of it starting with E and ending with E is the same as what? Right, so you have 12 divided by 180. Which is the same as 1 out of 15. And so that is the answer. to 1 out of 15 is the answer to 3.3. Then let's look at 3.4. What is the probability that such a word will start and end with the same letter? Right, so in 3.4, if it starts and ends with the same letter, okay, lots of questions here. Right, so let's look at that one. So if it can start and end with the same letter, so that will be the probability here that it starts. Let me just do it here. Start and end with the same letter. That is the probability of the fact that it starts and ends with E. Whereas the probability of the fact that it starts and ends with T. Okay, start and end with E, we said it's 1 out of 15. So T is going to be the same, 1 out of 15. So if it starts and ends with the same letter, we saw that the probability was 1 out of 15. Also for T, because there are two, those T's, it's 1 out of 15. And so if you add the two, it's, in other words, starts and ends the same letter. If it starts and ends with E, or, so if we say or in probability, we add, right? And then, or it starts and ends with a T, which is 2 out of 15. During summer in a certain city in South Africa, the probability of a sunny day is 4 out of 7. And the probability of a rainy day is 3 out of 7. Right. If it is a sunny day, the probability that Vusi cycles to work is 7 out of 10. And the probability that he drives to work is 1 out of 5. And the probability that he takes the train to work is 1 out of 10. If it is a rainy day, here, what are we discussing? We're not just looking at these questions, but I'm looking at a case where they ask you in the exam to actually draw a tree diagram. So we are looking at the tree diagram to say, how do we actually do tree diagrams? So now that is one thing that is very important. Tree diagrams. Right, so tree diagrams. Okay. Okay. Now let's look at the next point. If it is a rainy day, the probability that Vusi cycles to work is 1 out of 9. The probability that he drives to work is 5 out of 9. And the probability that he takes the train to work is 1 out of 3. Okay, we are learning here how to draw a tree diagram from the given information so that we can use it to calculate probabilities, like indicate on your diagram the probabilities. So that is the skill we are learning. We looked at something which was called two-way tables first, and then we shall look at Venn diagrams also. So we're looking at the tools that come in probability. And then we shall look at the graphs on calculus as well. Okay, so yeah, that is one thing. Right. Right, so we have that. Right, so we are continuing. We are continuing. Okay, so now draw a tree diagram to represent the above information. Indicate on your diagram the probabilities associated with each branch as well as the outcomes. Okay, so for 5 marks, let's just enjoy ourselves there. And then see what else you can do. You know that it is way, way too easy to do this one here. So we are so good. So good. Let's get started. Right. With the tree diagram. All right, so we have exactly that part there. Um, okay. In just a minute, we're just doing that one, and I'm sure that you'll understand the tree diagram. Okay, we're doing tree diagrams now. We're just discussing probability. So, but when we discuss probability, it's very important that you know how to deal with the two-way tables, how to read the totals for probability calculations. How do you read totals from a tree diagram? Now, that is something that is very, very important because it's going to be there in the exam. Either they bring this tree diagram, or they bring a Venn diagram, or they bring a table, what you call the two-way tables. So one of those is there, right? Because they've no other thing to ask. It's not. It's metric is not like university. You don't have lots of things, so it's just a very few things. Okay, let's look at this one. Right. So this tree diagram will start and end somewhere. For example, right? It will start and end somewhere. And if it starts and ends somewhere, we're good enough. We are good enough. Right. We are good enough. Right, we're good enough. So we continue. We continue. Okay, I'm looking at the tree now. Okay, I know that you have seen the tree but diagram, but yeah, we're preparing for the exam because they can bring exactly this question, like this one. They will bring a story. If they don't bring a story, normally they will bring a story, or they'll bring something else, you know. Right. So now let's look at the tree diagram and how we draw the tree diagram. It's a bit messy, but yeah, we're gonna be good. Let me see if I can draw it somewhere. Let me draw it somewhere here. Let's look at 4.1. Draw a tree diagram to represent the above information indicated in the diagram the probabilities. Okay, let's start like this. Right, the probability of a sunny day is what? Is 4 out of 7, and the probability of a rainy day is 3 out of 7. So surely it is either sunny or rainy. It's either a sunny day or a rainy day. So the probability of a sunny day is 4 out of 7. So you put 4 out of 7. And the probability of a rainy day is 3 out of 7. We continue. Okay. Now, next, during summer in a certain city in South Africa, the probability of a sunny day is 4 out of 7, and that of a rainy day is 3 out of 7. If it is a sunny day, the probability that Boozy cycles to work is 3 out of 7. And the probability that he drives to work is 1 to 5. And the probability that he takes a train to work is 1 out of 10. Okay. So let's look at these. If it is a rainy day, the probability that Booty cycles to work is 1 out of 9. And the probability that he drives to work is 5 out of 10. And the probability that he takes a train to work is 1 out of 3. So Um, okay, right, we look at the next one. So yeah, we're gonna do that one. So the probability here, let me do it like this, it's gonna be a bit messy. Right, so what do we do here? Okay, if it is a sunny day, like sunny, the probability that Vusi cycles to work is 7 out of 10. Sunny, 7 out of 10. Okay? So if it is sunny day, probably that he cycles to work. So he cycles to work, or he drives to work, or he takes a train to work. So he might, it is, so this is one is gonna be sunny and he cycles. Here it's gonna be sunny and he drives. Here it's gonna be sunny and he takes a train. So the probability that he drives to work is 1 out of 5. The probability that he takes a train to work is 1 out of 10. Okay, next. If it is rainy, the probability that Vusi cycles to work is, it is rainy. It is rainy. The probability that Vusi cycles to work is either cycles or he drives or he takes a train. But yeah, the probability that he cycles to work is 1/9. The probability that he drives to work is 5 out of 9. And the probability that he takes the train to work is 1/3. So either, in other words, here it's it's a rainy day and he cycles. It's a rainy day and he drives. It's a rainy day and he takes a train. So we're done. So 4.1 was like draw a tree diagram to represent the above information. Indicate in the diagram the probabilities associated with each branch as well as the outcomes. So we have indicated this one as well as the outcomes, and therefore we are done. What are the outcomes? The outcomes are these ones. It's sunny and he cycles. It's sunny and he drives. It's sunny and he takes a train. It's rainy and he cycles. It's rainy and he drives. It's rainy and he takes a train, because we draw to represent a bioinformation indicator diagram the probabilities of these. Any question? Next. Okay, in 4.2, we are continuing right now. In 4.2, we are looking at the day selected at random. Yellow, my dear. Is it? Yeah. All right. Yeah, I'll think that the class, my dear. Okay. Okay. That's fine, my dear. Right. So you have for a day selected at random, what is the probability that it is right? So let's look at 4.2 now. For a day selected at random, what is the probability that it is rainy and Vusi will cycle to work? Let me give you like, okay, because it's 2 marks, let me give you like 2 minutes and you do this and then we shall do the corrections together. 4.2.1. Okay, anyone, please let me know when you're done. Please let me know when you're done.
Answer.
You done, eh?
Yes, sir.
All right, all right, all right. What do you think the answer is gonna be? Just curious. Then we're gonna do it.
Sir, I'm not sure.
Okay, that's
If
fine. That's fine. Never mind. Never mind. Okay. Right. For a day selected random, what is the probability that it is rainy and Vusi will cycle to work? Okay, look at this. Right. So in other words, it is rainy. It is rainy and cycles. So now, rainy and cycles, let's come here. So if it is rainy, the probability that it is rainy, either it's sunny or rainy, but the probability of rainy day is 3 out of 7. So you come here, put 3 out of 7. Okay, I'm just teaching you how to read, how to do probabilities from a tree diagram. And then now, if the probability of a rainy day is 3 out of 7, and then now it's not only rainy, but cycles as well. So rainy and cycles. So cycles is top. So we did 1 out of 9 there times 1 out of 9. And then now this one is 3 by 1, which is 3 out of 63, which is exactly 1 out of 21. So you have that. Right, so that's the answer. Okay, the next one, I'm gonna just give it to you for a little bit, and then we gonna do the thing. Right. So Vusi takes the train to work. Remember that for a day selected at random, what is the probability that it was rainy and it cycles to work? Now the day selected at random that Vusi takes the train to work. Please calculate that one. Please let me know when you're done. Okay. So please let me know when you're done. Okay. Please let me know when you're done. Okay, let me do the corrections. I'm just giving you so that you can think, because see, all the things are like easy, everything is obvious, but you need to learn how to think. You need to like try the questions first. Then you can learn, because then you realize, oh, okay, this is what he did. Okay, I was thinking about this and I was thinking of how to do it. I was thinking of doing it differently, you know? Um, 4.2.2. For a day selected at random, what is the probability that Vusi takes the train to work? Right. So now, remember that it's a day selected at random. What is the probability that, so a day selected at random either, but it takes a train. That's the thing. So it is either a sunny day and it takes a train, or it is either a rainy day or it takes a train. So it's one of those. Either it's a sunny day and it takes a train, or it is a rainy day or it takes a train. It's a day selected at random. Right. So what is the answer to this here? Right. So can you have a situation? So this one is going to be the probability of sunny day, a train, the probability of rainy day, a train. But can you have a situation where minus, okay, this formula has a minus, then you put a minus the probability of sunny day, a train, and rainy day, a train. What is the probability of sunny day, a train? So
1
the
out of 10,
probability
sir.
of sunny day is 4 out of 7. But sunny day, a train. A
So
train is 1 out of 10. Plus, now you come to the probability of the train or of the rainy day. So rainy day is 3 out of 7. Then train, rainy day and train is 1 out of 3 here. And then you do everything, it is 1 out of 5. So the probability that Woody takes the train to work and he cycles, or he rather takes a train to work, is 1/5. If Vusi works 245 days in a year, on approximately how many occasions does he drive to work? Okay. Is the question that needs to be done in 4.3. Is exactly that. Please try that one for 4 minutes, 3 minutes, 2 minutes, etc. And then we shall be back at it together. Shall we back at it together? Okay. Okay, let me know when you're done. Okay, I know that you're trying. Let's do it together. So now this one here is going to be 4.3 answer here. The probability of driving to work. The probability of driving to work. This is 2. To work. Of obviously, to find the probability of driving to work is the probability of a sunny day and he drives. Because if Vusi works 245 days in a year, on approximately how many occasions does he drive to work? So for him to drive, either it is sunny and then he drives, or it is rainy and he drives. So sunny and he drives, or rainy and he drives. Which is the probability of sunny and he drives, or rainy and he drives? The probability of sunny and he drives. Okay, sunny is 4/7. Drives is 1 out of 5. Here, 1 out of 5. Plus, then rainy is 3 out of 7. Rainy drives is 5 out of 9. Okay, calculate everything. It becomes 37 divided by 105. Okay. So now let's look at if Vusi works 245 days, this is the probability, it's this, which is the percentage that he drives. So if he works 245 days in a year, on approximately how many occasions does he drive? So this one is a tricky question, but very nice question. So you say the number of days times 245. Right. So obviously the percentage that he drives is the probability, which is 37 out of 105. Then times 245 days, you multiply, and the answer is 8, approximately. Obviously, we're finding number of days. So we have this. We have this. So in the end, then you have actually 8. You have exactly 8. Okay, so that's the answer. Because if Vusi works 245 days in a year, on approximately how many occasions does he drive to work? It's messy, I understand. Obviously, you will have a chance to watch the video and make sure that you actually able to follow this discussion. Right, let's continue. Okay, I'm just focusing on probability. Also, one way of setting the probability question would be that you have a Venn diagram like this. Okay, and now you need to do calculations based on the Venn diagram. Let's look at this question about the Venn diagram and make sure that you understand this. Okay, a survey was carried out with 240 customers who bought food from a fast food outlet on a particular day. The outlet sells cheeseburgers C. C also shown there as part of the Venn diagram. Bacon burgers B, and vegetarian burgers V. The Venn diagram below shows the number of customers who bought different types of burgers on the day. So this one shows the number. So the Venn diagram shows the number of customers who bought different types of burgers on the day. Okay, so let's continue. Let's continue. Let's continue. Right, so how many customers did not buy burgers on the day? How many customers did not buy burgers on the day? Right, so let's look at this question and answer it together. Obviously, now we're just reading the Venn diagram. This one is an easy one. Then I'm gonna also discuss with you some Venn diagram questions that are a little bit tricky and require you to analyze a little bit more. But obviously, you understand that this one is not a very difficult question, so it's very, very straightforward. So let us get this one right. So the how many customers did not buy burgers on the day? Obviously, these ones did not buy anything. So a total of 5 customers did not buy anything because they're outside. They did not buy cheese, or did not buy bacon, or they did not buy vegetarian. Are events C and B mutually exclusive? Give a reason for your answer. Are events C and B mutually exclusive? Give a reason for your answer. Let's look at obviously C and B. Are they mutually exclusive or not? Well, we can see that the big answer is a big no. Why would C and B be not mutually exclusive? Why? Because for mutually exclusive events, the probability of B and C must be 0. But here, the probability of B and C, looking at what is here, there's something there. So these events, the probability of the intersection is not 0, meaning that the probability of B and C events C and B mutually exclusive. Give a reason for your answer. Right, so we can see clearly that the events B and C are actually not mutually exclusive, because the probability of B and C is actually not 0. Look at that. Next, a customer from this group is selected at random. Determine the probability that he or she bought only a vegetarian burger. Okay. Okay, let's look at this question. Right, so here, a customer from this group is selected at random. Determine the probability that he or she bought only a vegetarian burger. Okay, we continue. We continue. We continue. Right. So, we continue. All right. I was looking at this one. A customer from this group is selected at random. Determine the probability that he or she bought only a vegetarian burger. Right. So we're analyzing that as follows. And we're saying a customer from this group is selected at random. Determine the probability that he or she bought only a vegetarian burger. Right. So obviously we're analyzing that together. So in 10.3.1, the probability of a vegetarian burger is going to become what? Right. So let's look at this carefully. Remember, here we're saying bought only a vegetarian burger. Only a vegetarian burger. So here, if you say only a vegetarian burger, so it does not have anything to do with the other burgers, okay? And we are back to your question, Marang, about the total we use. What total do we use from the table? Okay, because there is a tape, there's a total for the vegetarian. Total for the vegetarian is 9 plus 12 plus 3 plus 58. But if we're saying they bought only a vegetarian burger, it actually means that in 10.3.1, only a vegetarian burger is going to become 58. Remember, it's only a vegetarian burger, so it's going to become 58 divided by 240. You get the point? It's going to become 58 divided by 240. Right, so that's what we have here. All right, so that's what we have. Right, so if you look at 10.3.2 now, they're saying bought a cheeseburger and bacon burger. Right, so let's look at that one. So a customer from this group is selected at random. Determine the probability that she bought cheeseburger and bacon burger. So if you look at cheeseburger and bacon burger, 10.3.2, cheeseburger and bacon burger. Right, so cheese and bacon. So in other words, at that point, you're looking at these 17 and 12, which is exactly 29. So cheese and bacon burger is 29 divided by the total number, which is 240. Right, 29 out of 240. Now, did not buy a cheeseburger. So, in other words, if you look at the fact that a customer from this group is selected at random, determine the probability that she did not buy a cheeseburger. So let's look at that one. So in other words, there is no cheeseburger. So in 10.3.3, no cheeseburger, it means that you have other things like potentially, but you're cutting out cheese. So you might have, if you have a 52 plus a 58, which is 100 and what? Which is 110, 113, 118. So did not buy a cheeseburger, so no cheeseburger will be 118 out of what? So we don't only consider the cheeseburger, but we consider every single bit of thing to find the probability total, which is 240. So it's 118 over 240. 118 over 240. So that would be the probability that they did not buy a cheeseburger. What is then the probability the probability that she bought a bacon or vegetarian burger. Right. So if you look at bacon or vegetarian burger, okay, let's analyze that together. So bacon, or so it's not bacon and, for example, so bacon and vegetarian, B and V would be in here, would be like 15. And that would be B and V. So, but now if you say B or V, so now you'd have to consider B or V. So in other words, it's either B or V. Okay, so we continue. We continue. Okay, let me give you like 2 minutes. And you do that one for 1 mark. Bacon or vegetarian? Yeah, just do that one, please. Please just do that one. Bacon or vegetarian? Right. Right. So, but also, if you look at bacon or vegetarian, 10.3.4. So bacon or vegetarian would become what? Right. So let's look at this one. Now, bacon or vegetarian means that if you add everything in bacon, so it's either bacon or vegetarian. Let's consider bacon or vegetarian. What's bacon? Bacon is going to be this here, so 17. Okay, this one is going to be 15, and then 32, and then 34, and then 80, 86. Okay, let's check 15. This one is 15, and then this is 32. Yeah. 34, and then 84. And then 84, you add 9 to 84, which is 93, 93 plus 8, which is exactly 101, and then 151. Good. So if you look at both, so you have 151, which is bought a bacon or vegetarian bacon. So it's 151 divided by what? By the total of everything with this outside. So on the table, it's a total that sits here. We're looking at that to a table we study. So this is then 240. All right. If it's 240, then you continue. You divide here. So if you have 151 divided by 240, what do we get? So it's 151 divided by 240, and that is the answer. Okay, this is enough. Yeah, you can use a calculator to find the decimal equivalent fraction of that. More probabilities. Let's look at the marbles and the tree diagram again. This tree diagram is way too congested. Is way too congested. Is way too congested. So, okay, there is this question about Babalo. Babalo has a bag containing 80 marbles, okay, that are either green, yellow, or red in color. 3/5 of the marbles are green, 10% of the marbles are yellow. Babalo picks 2 marbles out of the bag, one at a time, and without replacing the first one. So this is without replacement. This is without replacement. It is without replacement. Okay, let's look at this now. How many red marbles are in the bag? Okay. So, but obviously here, if we want to find how many red marbles are in the bag, okay, look, 3/5 of the marbles are green, 10% of the marbles are yellow. Right, 80 marbles are green, that or that, okay. So, how many red are in the bag? So we continue. We continue. Okay, try what 11.1 and then we shall discuss together. Please try 11.1, guys. And then I'm gonna discuss with you in like 2 minutes. I'm giving you 2 minutes to try 11.1. Okay. Hello, my dear. Yeah, because I was trying to plan the whole thing. But yeah, but I was trying to also look at what we can do. So I decided to send a message now. Yeah, so please check the message, my dear. Yes, please. Yeah, on WhatsApp. Because I'm planning and I'm looking at what can be done. But I'm still having my class now. Okay, my dear. Okay, so how many red marbles are in the bag? So look at that very carefully and think about it. How many red marbles are in the bag? Okay, so anyone done?
I'm done, sir.
Okay. Okay. What do you think? How many are there? Maybe if I can ask, Dave from Marang. What you think, Marang?
So I got 24 marbles.
Okay, that's fine. Let me see. Well done. Okay. So that's correct. So obviously you need to look at the percentages because now you need to look at the fact that 10% of the marbles are yellow. Okay. So now if you have 10% of the marbles are yellow, and then now you have here, what percentage is this one? So there are many ways to do that. So you divide this one by 5, which is 0.6. So it's going to give you like a certain percentage, like 60%, right? So if you divide by, yeah, 5 divided by that is 0.6. Can you use a point? 0.6. So in 0.6 is like 60%. And then now, if you look at these now, obviously you have 30 and that, which is exactly 70. So it means, therefore, the remaining ones, to make 100, you have 30. Over 100 multiplied by the total number of the marbles. Okay, we're dealing with 80 marbles. Right, we're dealing with 80 marbles. So dealing with 80 marbles now is going to give you a total of 24. Right, because if you're saying how many red marbles are in the bag, so you're dealing with a total of 24 marbles that are red. Okay, draw a tree diagram to represent the above data. What is the probability that Babalo will choose green and yellow marble? Okay, so we have that. So all right. Now you have, okay, what is the probability that Babalo will choose green and yellow? Okay, but let's look at these very carefully. And think of the fact that Babalo has a bag containing 8 marbles. Okay, some of the marbles are green, some are yellow, and some are red. Okay, we analyze that together. Now, the green ones, the green marbles, would be, for example, okay, let's look at the fact that the green, how many greens are there and how many are red? Okay, obviously you've seen that. Marang was able to determine that there are 24 out of 80. 24 out of 80. And then now the green ones, how many are green? Obviously we said 60%, so you get 60% of that. So if you find 60% and then you multiply by 80, you'll get the total number of the green, okay? Because the green, green are 3 out of 5, okay? So those will be 48 out of 80. Yellow, how many yellow would be there? So those will be 8 out of 80. So we have these. Now, okay, let's look at these carefully. Now, if you look at the fact that you have green now, okay, if you have green, remember that we are looking at the fact that these marbles are 80 in some those colors of yellow, green, red, right? And obviously they pick 2 marbles. They pick 2 marbles. So if they pick 2 marbles, the first pick is going to be either if you pick the color, it's going to be green, yellow, or red. And then they pick for the second time. So if they pick for the second time, it can either be green, yellow, or red. Okay, they also pick here. So it can be green, yellow, or red. But there is a second pick here. So you have the arm of the tree. It can also be a green, yellow, or red. Okay, they do green, green. If you do green, green, okay, let's look at the fact that, okay, now are they with the replacement? Okay, without replacement. So when you pick the marbles from the bag, you decide if you replace or not. But in this question, they're saying we don't replace anything. So if you don't replace, then it's green, green. Right, so it's 48 out of 80. It's 48 out of 80. And then now also this one is 48 out of 80. And this one is 48 out of, yeah, okay, 80 out of 80. Right. You don't replace. So after you picked 1 marble, out of 80, how many will be left? Would be 79 marbles left. Out of 80, there will be 79 marbles left. But you don't replace. So it means that also you would have 47 to choose from. Right. So also you have 79. Okay, if you deal with the yellow. Okay, obviously we're supposing that you the one you picked is green. Okay, we're supposing that the one you picked is green. Yes, please. How are you? Yes, that is my. Oh, okay. That's a student is calling me. All right. So we continue. So okay. In the first case, okay, now look at this very carefully because this is how we draw a tree diagram, and they can ask you the tree diagram in the exam. So if they choose green, okay, if you pick from the bag and you pick a green one, so it means the yellow, how many yellow marbles were there altogether? Okay, let's just write the numbers of the marbles in case we forget. Okay. 24. So let's look at these. So we're looking at red. Okay, let's look at red. Red are 24. And then let's look at green. Okay, they are also here. You can see them here. Green, 48. How do you get 48? Okay, 48 is obtained by 60% of 80. Right, then you have yellow. How many yellow? Yellow are 8. Right, so this is what we get. Okay, now I want us to look at this. Yellow would remain 8 out of 79. You picked a green marble, so you're left with 79 because one out of the 8 marbles, the green one has been picked out of the bag. Okay, here we have you picked the green one, so you're left with a total of 79. But what? But now the green, how many green? Right, the green are actually a total number of, okay, I need to check the green. So how many green are there? Very carefully. Right, obviously we said that the green is going to be, okay, look at this. It's going to be 3 out of 5 times 80, which is 60% times 80. Times 80. So obviously if you, this is 0.6, okay, you multiply there. All right, I need to check this carefully. So you have 60% times 80. Right, so if you have 60% times 80, so you have 80 times 60. Okay, then you divide by 100. Okay, we're getting 48. So indeed, obviously, once again, I mean, it confirms that we have 48 here. So just a sec. Yeah, okay, we dealt with the green. Oh, now we're dealing with the red. The red will remain 24. Let me write here. So you can write 24 here, but it's 24 out of 79. Okay, if you look at the red, 80, 8 out of 80. Green. Okay, in the second case, if you pick from the back, suppose you pick a yellow marble because you picked green. So you can pick a yellow marble. Remember, the yellow marbles are 8. So that is going to become 7 out of 79. And then the green will remain 48 out of 79. Right. Right. Okay, we continue. Okay, we're just doing this tree. I know it's very untidy, you know, it has too many things. Now let's do red, for example. Okay, we're going on. Right, we are going on. We are going on. We are going on. Okay, now, okay, let's look at the, okay, let's look at the red ones. Okay, obviously here the red will remain 24 out of 79. Okay, if you look at the green, all right. Okay, let's continue. Okay, let's look at the green. The green are 48. Okay, you're picking one maple, so you're gonna be left with 79 from the back. The yellow will remain. Okay, we picked yellow, so yeah, we're gonna pick red. Because the yellow were 8, we picked 1 plus 7. Now the yellow 8 out of 79. The red, okay, now you're picking red. We picked the green, yellow, then red. Okay, picking red now, red will be 23. 23 out of 79. Okay, 23 out of 79. Um, right, so it's 23 out of 79 for the red. Okay, let's look at the outcomes. What are the outcomes? The outcomes is going to be green, 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 yellow, green, red, green, red, then red, green, red, yellow, red, red. This one is going to be red, red. Those are the outcomes. Red, green, red, green, red, yellow. Um, okay, we'll continue. Okay. Okay, you have this. Okay, I lost Senulu. I lost Senulu. Okay, you have this. Right, so you have this here. You have exactly this. Okay, so we have that. Right, so okay, we continue. I was at the okay, here you have red. Yeah, okay, I was looking at red, yellow. Okay, I know this is just too congested. Red, red. So the bottom one is going to be RR. Right, so we continue. Right, so draw a tree diagram to represent the above data. So to draw a tree diagram to represent the above data, it is 3 marks. Okay, so It is the data represented. I know it's just too congested. I was trying to squeeze the whole tree here, but the outcomes are visible. Okay, if you look at 11.3, what is the probability that Babalo will choose a green and yellow marble? What is the probability that Babalo will choose a green and yellow marble? Okay, green and yellow. Right, so that can be done in the following ways. So you can look at the probability of green, yellow, green, yellow. Right, so you have green, yellow, or the probability of yellow, green. Okay, is either it happens green, yellow, or yellow, green. That is how he's actually having, is gonna have green and yellow. Green and yellow, both of them. So let's do the probability here. So this one is gonna become the following. So what is the probability of green? From here, green is 4880. The probability of green, then yellow, is 8 out of 79. Or is plus. Okay. And then you have here yellow. It's 8 out of 80. Yeah, okay. Then we have yellow. Then green is 48 out of 79. Which is 48 out of, if you do use a calculator here, it's going to become 48 out of 395. That is the probability of green and yellow. It's either green, then yellow, or yellow, then green. You have those probabilities and you then add them up. And then you add them up like that, okay? Right, let's take a break. And we shall come back again. So I'm gonna send you the time. What time can we meet again? If you guys are free, anyone free? Anyone free at, I know some of you guys do not like nights. Okay, think about 8, 8:30 p.m. if you are
Me,
gonna
I'm fine at night, sir. I
Pardon?
also can do night. Me, I can also do night. It's fine.
Oh, okay, that's all right.
12 o'clock, 1 o'clock until 5. It's fine.
Any time of the night is okay.
Yeah, it's fine.
Yeah, thank you so much for that, Tenulo, because it's gonna help you a lot. So I'm planning that we meet at 8:30. I would make it much later, but think about it, 8:30. So, right. So Marang, think about it. Okay, let me know.
Yes,
Because when I
8:30.
please come again.
8:30 is fine, sir.
All right, yeah, because it's injury time. It's injury time. So every minute counts, you know, because the exam is here. So we shall meet at 8:30. I'm gonna bring more past exams at 8:30. More past exams and more graphs at 8:30 because something that's difficult is paper 1. That sometimes becomes tricky at the graphs. So yeah, I'm gonna see you exactly at 8:30. Okay, I'm gonna make sure that I'm there at 8:30. Okay, so that we do something. All right. Okay, guys. Thanks. Bye for now. I'm gonna post the video now. Thanks, guys.
Okay, bye, sir.
Guys, goodbye.